type of naming we're going to talk about is compounds that have two nonmetals. So compounds with two metals have bonded in a different way. They do not have what we call an ionic bond. They have something called a covalent bond. They share electrons. We'll learn more about bonding later, but what you need to know at this point is because they're not ionic, there are no charges involved, and therefore we cannot use crisscross. So sometimes you might look at some of these elements on the table, and they do have the charges still listed there, but when we're naming with two nonmetals, we don't want to use those charges. The big thing to look at here is we're going to have two elements from the right side of the staircase. So this is the same side of the staircase naming. It's important to put your fingers on those elements, see that they're on the same side, and that will let you know that you're not crisscrossing, but instead you're going to be using prefixes. Many people find this to be an easier type of naming and formula writing, but you do have to keep in mind that you're not worrying about those charges, you're not looking them up, you're not crisscrossing. So we're going to start with writing a simple compound, SiO2. So Si, and the first thing I like to do is just check what kind of naming I'm going to use. So if you put a finger on Si, put a finger on O, you'll see that they're both on the right side of the staircase. So we have silicon and oxygen. Now we have to tell people how many of each of these we have. We can't just call this silicone, oxygen. We have to actually be a little bit more clear than that. We have one silicone. So we're starting with our one silicone. Now the one thing that's kind of interesting here, we do have a prefix for one, mono. We don't use the prefix mono first though. So if a compound starts with one of something, in the case of silicone, we're just going to use that, or we're just going to drop that and just say silicone. So the reason I'm not using a prefix is because there's an invisible one here, and we never write mono first. We will look at examples where mono comes second, and then you do write it, but this is not that example. The second thing we have is oxygen. And we have the prefix, we have two oxygens, the prefix for that is di. So this is going to be silicone di. And again, oxygen's from the periodic table, so we're still changing the N to I. So silicone dioxide. This might sound like a compound you've heard of before called carbon dioxide, so this is a little bit familiar to us. Si2Br3. So we have sulfur, and we do want to keep these in the order that they are written in. Start by showing this is bromine. We're going to use prefixes to show how many of each are present, and I'm just going to jump down here. We have two S's. The prefix for two is di. So this is disulfur. And then the second part is bromine. There's three of those. The prefix for that is tri. Tribromide. We're still changing that I ending. Notice this stayed sulfur. So the first thing, it's not disulfide tribromide. It's not that. Only the very ending gets changed to I. So it's disulfur tribromide. Here are a few examples for you to try. Pause the video, and I'll put the answers up. So carbon dioxide is an example of that. We don't start with the mono rule. I like to contrast that with carbon monoxide. So in this example, we only have the one carbon here, so we just said carbon and then dioxide for those two oxygens. Our second example, we have one carbon, so we just say carbon first. We have one oxygen, but we do use that mono prefix on the second species. So that's carbon monoxide. My trisulfur means I have three sulfurs. Tetrafluoride. For N2O2, we have two nitrogens. That's dinitrogen dioxide. Often I get the question on this one, why isn't that reduced? Because we didn't crisscross, we don't reduce. That is actually how that compound is bonded, so we have to leave it that way. And then finally we have sulfur hexoxide. It's a fun one to say. You also need to be able to take one of these names and write it in symbols. So we have tetrasulfur, so that's the sulfur part of this. And nitride is representing nitrogen. That "ide" ending tells us we go to the periodic table. And then based on our prefixes, so tetra means 4, di means 2, So this is going to be S4N2. Again, we didn't crisscross, you're not pulling any charges, so don't simplify or reduce. It's okay that this is not in the lowest whole number ratio. Tetrasulfur, dinitride, S4N2. Dinitrogen monoxide. So we have nitrogen, oxygen, 3 and 1. So this is N3O. Here are a few for you to try. Pause the video, give them a whirl, and I'll pull the answers up. So sulfur, we dropped that mono on the first one, so that's just 1 sulfur, 2 oxygens. We have 2 phosphoruses and 4 oxygens, 3 nitrogens, and 5 oxygens. So hopefully those are pretty straightforward. Usually people find this to be a pretty easy type of naming.